Good evening. Let's wait for 2 more minutes, then we'll begin. Yes, good evening, Sandeep. Welcome to Unacademy and welcome to my class. We'll just wait for 1 more minute and then we'll be starting. So, in the last class, we have covered the data structures. Now, as per the NCERT syllabus, you had to learn both stack and queue. And since we have covered the portions of stack and queue, today we'll be having a discussion on the different questions that are likely to come from the chapter. Okay, so just 1 more minute and then we'll start off with our discussions of the questions. A few of them, the application level questions we had already seen. So we'll be just looking into a few of the conceptual questions and one or two of the application based which we have left or which we hadn't covered when we were learning the others. Okay. So yes, that's it. So very good evening to all of you. Welcome to Let's Crack CBSE Science. So before moving on to our lessons, let me give you a self introduction. So I hope all of you are safe, sound, and healthy. Hello all, I am Shalini. I am a BTech and MTech holder in computer science and engineering. I'm a teacher by profession with over 14 years of teaching experience teaching various engineering undergraduate students. And with Unacademy, I'm excited to provide an inspiring learning experience to all the students via this online platform. So next, before pitching in, let me give you a brief tour over the different subscription details of Unacademy. So as you all know, Unacademy is India's largest e-learning platform and it is treated as the one-stop destination for all the courses. Say for example, from a school-going student to an aspirant who's preparing for a competitive examination, you get courses underneath Unacademy. Now to get the services or the to enjoy the resources of Unacademy, you need to take the subscription and I'll give you the details on the subscription. So the courses are from the best educators all over India. So this is a detailed description of what you get in Unacademy. You get access to the daily live classes. All the courses here are well structured. Yes, good evening, Vishwaraj. It's long time since I've seen you. So all the courses here are well structured. There are live tests and quizzes and unlimited access once you get a subscription. to Unacademy. So you needn't worry if you miss out a live session, because once you get a subscription, you get access to the resources as I mentioned, all the live as well as recorded courses which can be viewed at the comfort of your time as well as your device. Okay. Now I told you that the courses are well structured, or that means they are in line with the current examination syllabus. So this would help you to prepare for the examination better. Okay. And from the best educators all over India. Now, the test and quizzes would help you in giving an analysis of how well you are getting prepared yourself for the forthcoming examination. Now, this is how the comprehensive syllabus would look like. You would have the different subjects, and underneath each subject, you would be having the different courses that are being offered by the various educators, which you can view based on your requirement. Now, this is the Unacademy Learning app, which you need to download and install in your smartphones. Okay. So I repeat, it is the Unacademy Learning app that you need to download and install in your smartphones, and take the subscription based on your choice. Apart from that, there is a Telegram channel. All you need to do is download the app and type the link as a link shown in the picture here, Quest 12 CBSE Commerce. So you just need to join this channel to get the updates about the various courses, upcoming courses, and the materials posted by the various educators. Now, this is a detailed description about the Class 12 subscription fee details. Now, the fee details, the table shows the different plans ranging from a month subscription to a year subscription, and across each of the plans are listed the various fee structure also. But if you avail my promo code or my referral code SLYT, I repeat, if you use my promo code SLYT, you get a discount on the subscription fee. That is, you get a discount of 10%. So if you are wishing to take on a trial basis a month subscription which cost you around 2,500, on applying the code, this would give you a reduction in the rate, and this would be 2,250. Okay. So similarly, you have all the plans ranging from 1 month to a year subscription. So if you're a class 11 or 12 students, I would highly recommend you to take a subscription of either 6 months or a 12-month subscription based on your need. Now, this is not just for the class 12th or board examination, but also this would help you preparing for the JEE. Okay. Um, yes. Yes, good evening, Devika. Good evening, Deepak. Yes, Vishwa, after data structures, which is the next lesson. So after data structures, we'll be looking into the different sorting techniques, and then we'll be having lessons on files. So this is a chapter that I'm planning to take. So we'll be having consecutive classes in YouTube at the same time, as well as in the app also. The app that I'll be posting just 12 hours prior, but in YouTube it is usually 8:30 p.m. This is the time schedule that I choose for taking the live sessions in YouTube. Okay. Yes, hello, good evening, and welcome to my class. So, we have been dealing with the CBSE Class 12 Computer Science, and we had completed the chapter of data structure. So, as per the syllabus, NCRT syllabus, you had to learn both stacks and queues, and we had a small discussion over the questions. We had some worked out examples for the applications of stack also, right? And today we'll be looking into certain discussions on the conceptual as well as a few of the application questions which we had not covered on the previous class. So let's move in. Vishwa, which is the, yes, file handling after the sorting techniques. This is how that I have planned. Are you looking forward for file handling or for the sorting technique? Which is the one that you're looking forward to? So, yes. So, moving forward. So, the first question, very simple question. What is a data structure? So, data structure is a logical way of organizing the data in memory that considers not only the items stored but also the relationship among the items so as to give efficient and optimal performance. Now, this is the definition of data structure. Now, we also saw that it is a named unit. Okay, so every data structure would have a name associated with it, and it is using this name that we would be referring. File handling, yes, probably after our sorting technique. Definitely, yes. Only the two sorting techniques, that is binary search and linear search, that will be handling. Because it was asked in the previous year question papers also. But right now it is, I don't think a few of the portions are omitted as per the syllabus because of the pandemic situation. The syllabus have been cut short and a few of the topics has been reduced also. Okay. So yes, back to our question. So our question is, what is data structure? So as I told you, it is a named group, and this group, how is the group arranged? You have a logical way of arranging the data. So it is actually a group of data, not just a single data item or an element. And you have, it is a named unit. Okay. So there is actually a name associated with the data structure. Now, where are the data stored? The data are stored in memory. So, this data structure, it is not only considering the different individual element or data items stored, but definitely there is also a relationship among the data items. We had already seen the different classifications of data structure. Okay. So what was the different classification? It was divided into simple and compound data structure, and later the compound data structures were again classified into linear and non-linear data structures. So these were the things that we had came across as we were learning the chapter, the introductory topics on data structure. Now see the next question. Compare a data type with a data structure. Now what exactly would be the difference between a data type as well as a data structure? A data type defines a set of values. Again, we have a set of values here along with a well-defined operation stating its input-output behavior. Okay. Whereas, how about a data structure? Whereas a data structure is a physical implementation that clearly defines a way of storing, accessing, manipulating data stored in the data structure. So what exactly is the answer telling you? In the data type, what happens when you're writing, say, for example, the integer. Now, this is a data type. Now, with respect to the keyword integer or with respect to the data type, what does the word indicate? The data type indicates that it is capable of holding a value. Okay. Now, what is a property? You cannot store a floating point or a decimal value inside an integer, right? So, in this case, this is the restriction or this is a property with respect to a particular data type. But when you're talking about a data structure, it is not just a data item, but a group of data item, and the group of data item is collectively accessed. Now, every time this is collectively accessed means it is always acting as a unit, not as single data element. It is always acting as a single unit, and there are set of operations that are defined on the data structure which is implemented or which can be done on every data item or element stored inside the data structure. Now, this is what is meant by the way of storing. Now, storing is how it is arranged in the memory, accessing an operation that could be performed on it, and manipulating the data, any changes that you make to the data by insertion, deletion, or sorting. Okay, now all these operations that could be performed, and this would definitely bring a change to the data item or the element. So this exactly is the difference between a data type as well as a data structure. So moving on. Moving on to the next question. Differentiate between linear and non-linear data structure. Okay. Now, from the terminologies itself, we have a small hint on the what the data structure are. Now, priorly going into the differences, I would like to say that these are the classifications coming under the compound data structure. Now, what are compound data structure? Compound data structures or complex data structures are found or are formed using more than one simple data structure. Okay. So when one or two simple data structures combine to form a complex or a compound data structure, which are again classified into linear or non-linear. Now, what is the literal meaning of the term linear? Says linear meaning growing along a line, right? So anything that happens in a sequence, that is a particular sequence, and this is the order in which it is growing. Now, that particular category is defined as a linear data type. Okay. Anything which is not having a separate dimension and it can grow in any direction, that particular data type would be called as a non-linear data structure. Now let's see the difference. A data structure is said to be linear if its elements forms a sequence or a linear list. Okay, so it is simply like assuming it is growing in one direction, okay, or in one dimension. In that case, that particular data structure is termed to be linear since it's growing along a line. Now, the examples of linear data structure are stack and queue. The data structure that we are learning as per the syllabus is definitely examples of linear data structure. Yes, Gokul, good evening and welcome to my class. Now, how about a non-linear data structure? A non-linear data structure is the traversal of nodes is non-linear in nature. Now, example is graph and tree. Now, we had already seen that when we learned the introductory topics on data structure. Now, what did you say? What did I say? Now, when you're considering a tree or a graph, you had nodes and then you had the connections or the edges, right? So how would it look like? You would have a root node and then from the root node you would have different nodes connected to it. Now in that case, were you traveling along a line or in a sequence? No, right? You could travel along any direction based on that, on the condition that there exists a connectivity. Whenever there is a connectivity, in linear data structure, are the elements stored continuously? Yes, when you're considering the sequence of elements, definitely it is stored continuously. See, when you're considering in other programming languages, you have a concept called arrays. Now, which are the best example for telling a linear data structure. In that case, when you're talking about arrays, how the elements are arranged is you can think about a linear box, a rectangle box. Now this rectangle box can be divided into individual cells. Now inside the cell, an element would be residing. Okay. Now this collective unit is called as an array. And suppose imagine that this is in array A of the name A and it is holding integer values. Let me give wild guesses like 10, 100 and 90. Okay, fine. Now, each of this cell would be having a position number attached to it. Okay. So if you want, you can have an access to the individual element. Also, you can have the access to the entire array. To access the entire array, you just need to access it using the name. If you want to access an individual element from the array, it is like accessing the name of the array plus the index or the position value. So if you're giving A of 0, it indicates to the element in the array A at position 0, which is the element 5. So this is how you would be addressing an element inside the array. Now this was the case when I was talking about C or C++ or Java. Now the same thing, arrays is a concept in Python. It appears in the form of list. Okay. So whatever or however it was stored in the case of arrays, the same property is being carried out here also in the case of list. Yes, arrays and linear list are almost the same. It is just that it is not existing in Python. Instead, it is existing in the form of linear list in Python. Okay. So I hope this is clear to you. So definitely they are being stored in contiguous memory location or very near to each other. Do not confuse linear list with linked list. Linked list is something else. It is a data structure. Linear list is a data type. Okay. So these both are different. I hope you know the difference also. So, back to our question, we were discussing the linear and non-linear data structure. So, when a data structure is non-linear means the traversal of the nodes is definitely non-linear. You can travel in any direction provided there is a connectivity in the paths. A tree or a graph would look like something like this. The one in circle are supposed to be the nodes, and then you would have elements inside the nodes. Okay, now these are all integer values, and this is how it would look like. Okay, the one at the topmost will be your root node, and the one at the bottommost or at the lowest level are considered to be the leaf nodes. We had already seen that. Okay, now just understand the difference between linear and non-linear data structure, as well as the examples that would be coming under the linear data structure. Which are they? Definitely the data structure that we have to learn as per the syllabus, that is stack as well as queues. Okay. Now, what are the common operations that can be performed on data structures? Okay, so this is the next thing that we're going to learn. What is it? The common operations. So these are the common operations that we usually encounter in data structures. Now I have listed around 5 of them. The first one is insertion. Insertion is nothing but addition of an element, or to add or insert a new element to a given collection of data items. Okay. Now, what is the next thing? Next is deletion. So, what does deletion means? To delete an existing data item from the given collection. So, you have a collection of values or data items, and then if you're trying to remove an element or delete an element, the process is deletion. Now, what is traversal? Traversal, the literal meaning says traveling, right? Traveling means each time you're visiting a particular data element from the collection. Now, what is a collection? The collection is definitely the data structure. You would have a collection of values. So, traversal means to access each data item exactly once so that it can be processed. Is the idea clear? Now, in our case, when we were having the data types as well as the data structures when we were learning, how did we implement the traversal? We just visited each element, and to mark that we have visited this particular element, what did we do? We printed the value, right? So similarly, traversal or traveling each of the position. Now, which is the next operation? Searching, right? The searching means to find out the location of a data item. Okay, there are different searching techniques. Now, to search a value, what you do is you would first read the value from the user. Now, this value, you need to check whether this particular value that you have read from the user is present inside the data structure or not. How do you do it? You need to visit each of the position and check whether the value compare the values that you read from the user as well as a value in the data structure. And whenever you find a matching node, you conclude that the element is present inside the data structure. You travel the entire data structure and you do not find a perfect match anywhere. What is the end result? You say that the element is not present. Okay. So we'll be having one more class in which we'll be looking into the different searching techniques, primarily linear search and binary search. Okay. Now, sorting that we have already learned, we have learned two of the sorting techniques as per the syllabus, which were the bubble sort and insertion sort. Now, sorting means arranging the data elements in any order. Now, what is the order? The order is either ascending order or the descending order. So that means either in the increasing order or in the decreasing order. So these are the common operations that could be performed on any data structures. Okay. So next, what is a stack? Okay. A stack is an example of a linear data structure. Now we already saw that. So it is a linear data structure implemented in LIFO manner. Now what is LIFO? LIFO meaning last in, first out, where insertions and deletions take place only at one end, and this particular end is the top of the stack. So this is the definition with stack. Now we have seen that there is insertion operation as well as deletion operation in stack, right? Which is a technical term associated with the insertion operation. The insertion operation, the term is push, right? And for deletion, you associate the term pop. Now, how did you implement stack in Python? Stack was implemented using list, right? Using linear list. In that case, for pushing or for inserting, that means adding an element to the stack, you should definitely have a recollection of the member functions. I mean, not the member functions, the methods of list, right? Or the functions that are used in list. So for pushing, we use the method append. Now, whenever we are pushing an element or inserting, you need to specify which is the elements that you are going to insert. Is the idea clear? Whenever you are inserting or adding an element, you have to give the value of the element also. But when you're considering deletion, you just give pop. In the case of stack, I'm talking the case of stack and not any other data structure. Now you just give the method pop. Now what does pop do? Pop has two versions. One in which the function you would either specify the index value or you may not specify the index value. If you are just giving pop, what would it happen is the last element in the list would be deleted. So the last element meaning the one that is pointed by the top of the stack. Why? How is the last element being pointed by stack's top? Because stack is following LIFO order or last in, first out manner. Okay. So that's with regards to stack. Now let's see the different operations performed in stack. We had already seen two of the terms associated with it. Now the basic operations and the terms associated with stacks are push, pop, peek and display. Okay. Push meaning inserting an element into the stack. Pop meaning deleting an element from the stack. Now peek is visiting the topmost element without removing it. Okay. So peek is just visiting whatever is pointed by top. Okay. The variable top points to an element. Only that particular element is viewed, or the other name for peek is nothing but inspection. Right. What is the other name? The other name was inspection. And the next one was display. Now, what did display do? To view all the elements from the stack. Okay. So you would, in which order it would be printed? It would be printed in the reverse order in which they were inserted, since it is following the LIFO manner. Is the idea clear? So these are the different operations or terms associated with stack. Okay. Now moving on to the next question. Now, what are the applications of stack? Now, we had already seen them. Now, I have just listed five of them. Now, it is not just five, but we have a team number of applications of stack. Now, because of the LIFO property of stack, now it is this property of the stack that is being exploited for the following applications. Okay. Now, what are the applications? It is used for reversal of a sequence, then from conversion from an infix to a postfix expression, and the postfix and prefix evaluation. Then it can be used in the process of recursion, backtracking, etc. Now let's see each one of them in detail. Now what is a reversal of a sequence? Now reversal of a string. Okay, say for example a string. Now suppose I'm having a string of the name, say stack. Now when I'm trying to push the elements in the stack, what happens? Which is the first element that will be pushed onto the stack? S, right? Now I'm trying to read the string from left to right, in the direction of left to right. So the first character that would be pushed into is S. On top of S you would have T, then A, C, as well as K. Now what is top pointing to? Top would be pointing to the very last element that is inserted, which is K. Okay. Now when you're trying to pop the elements and empty the stack, how would it appear? And each time you're trying to print whatever is being popped. Okay. So I would get it as like this, right? This would be the output on the screen. Now what exactly is the output? It is the reverse of your string stack. Is the idea clear? It is the reverse of your string stack. So the most simplest application of stack is in the string reversal or reversal of any sequence. Now which is the next thing? Infix to postfix conversion. Now what is an infix expression? Any expression of the form a plus b, wherein the position of the operator is fixed in between the operands and hence infix. Okay, where is it fixed? What is fixed? The operator. The position of the operator is fixed. Now where is it fixed? It is fixed in between the operand values. When you have such a notation, this is called as infix notation. Now what is a prefix notation? Pre meaning before, right? So whenever the operator is fixed before the operands, it is called as a prefix notation. Now what are you left with? You are left with the postfix notation, right? Post meaning after. So after the operands, if you are fixing the operator, the position of the operator, the expression is called as a postfix expression. Is the idea clear? Now, in this case, for conversion from an infix to postfix expression, also stack is used, as well as for postfix and prefix evaluation, also stacks can be used. Now, what is recursion? Now, recursion is a technique in which you are repetitively calling a method or a function. Okay. So, when a function, say you have a function of the name f. Now, inside the function, if you are calling itself, now suppose f is taking a value x, and inside this function, if you are calling the function with a new value. Now this is a function call, this is a function definition. So how is the function call written? It is written inside the function definition itself. So a function f which is being called inside the same function, we call the process as a recursion, and we call f to be a recursive function. Why? because the function is called within itself. Now, here this becomes a repetitive call, right? Now, we know that whenever there is a function call, there is a jump from the point of call to the point of definition. Now, after the function has been completed, the control has to come back also. So when there is a recursive call from the point of call again to the point of definition, and such a retracing would be done. So every time after the function, a complete execution or a complete iteration, it has to trace back, right? Trace back in the sense it should have a return address stored somewhere. In this case, we use stacks for storing the return address. Why? Because definitely the LIFO technique is going to be exploited here. What is it? Last in, first out. Okay. So the innermost function has to be returned first. So the return address for the innermost function would appear at the topmost position in the stack. Okay. Now what is next? And the last application is backtracking, right? Now what is backtracking? Backtracking is nothing but tracing back or tracing a path in the reverse order. Now if you have to trace back or come back a particular path in the reverse order, definitely you should be saving the links or uh, every details about the path that you have visited. Only then you can travel in the reverse order. Now here again we use the property of stack. Which property? LIFO property has to be used. So definitely the data structure that we would be using is stack. Okay. So hence backtracking. Now next question, what are queues and what are the operations that can be performed on queues? Now we saw that stack is a linear data structure. Similarly, queue is also a linear data structure. But stack was following LIFO technique, and here queue follows a FIFO technique. What is FIFO? First in, first out principle. Okay. Now apart from that, the other things that you need to notice, in the case of stack, you just had one end of the stack which was the heading. That was the top of the stack. See, whatever you do, that is push or pop, you just need to keep in mind or remind yourself about the position of the top after each of the operation. But when you're considering queues, what happens? There are two ends for the queue, which are the rear end as well as the front end. Okay. The real-time queue, as we see, is a typical example of the data structure queue also. Here, the data are entered or insertion happens through the rear end and the deletions happens through the front end. So this is the understanding with regards to queue. And as we saw in stack, there can be insertion, deletion, peek and display. Now similarly, the same operations are there in the case of queue also. Now, when we learn stack, we also learn the term associated with insertion operation, which was the term push. And in the case of deletion, the term associated with pop, right? So similarly, in the case of queue, the insertion of an element, it is called as enqueue operation, and deletion of an element is called as the dequeue. Okay, these are the terms associated with insertion and deletion respectively in the case of queue. What is it? Enqueue for insertion and dequeue for deletion. Now, peek and display, it is the same as what we have learnt in stack. What are they? Peek, viewing the frontmost element without removing it, and display, or what does it do? Display is viewing all the elements in the queue. So these are the different operations with respect to queues. Okay. Now let's see the conversion of infix expression to the postfix equivalent. Now here I have given, I think, yes, three expressions. Now in all the three cases, the one with the small letter Roman numerals are the question. Now what you need to understand is there is no parenthesis being given here. So you need to travel every expression from left to right. Okay. Then understand the order of evaluation. Now, how is the order of evaluation identified? The first priority has to be given to parenthesis. Yes, good evening, Atul. Welcome to my class. So the first priority has to be given to parenthesis, second to exponentiation. Now, which is the symbol used for exponentiation? Exponentiation is asterisk asterisk, right? The third priority has to be given for multiplication and division, and the fourth priority for addition and subtraction. So the very first thing that you need to note is you need to travel the expression from left to right. So as you travel from left to right, okay, so first you encounter plus, okay, and then you encounter minus. You see that both of them has equal priority. So when in the single statement or in the single expression, you come across equal priority operators, which is the order to be followed. You follow the associativity, that is the direction in which you are traveling. So this has to be given importance. So which is the first operator that you encountered? Plus, right? So this would be converted to the postfix equivalent. How would it be? AB plus, and then you would write the rest of the expression. What is it? AB plus minus C. So this expression gets converted to this form. Now, this is your postfix notation with respect to A plus B, right? Now, consider this as an operand. Now, how is your expression looking like? You have an operand, you have two operands. First operand is AB plus and the second operand is C, and you have an operator in between both the operands. Now, this looks like an infix expression, right? Now, it is very easy to convert it to its postfix equivalent. How do you convert it? You first write the operands and then the operator fix it after the operands. So, you first write operand C. First operand is AB plus, followed by the second operand C, and then the operator, which is the minus sign. So this is how you convert a given infix expression to the postfix equivalent. Okay. Now let's move on to our second question. What is the second question? See, this is the second question. Okay. Now you travel from left to right. Okay. Now, as you travel from left to right, you see there is a plus, asterisk, minus, and then asterisk. So, we know that multiplication has to be given higher priority than addition or subtraction. So, what did I do? I introduced parenthesis just to indicate that this is a one that has to be converted first, right? So, B asterisk C in parenthesis as well as E asterisk F again in parenthesis. Now this would be the one that would be converted first. So how would your expression look like? A plus B asterisk C, when it is converted to postfix, it would be operand followed by the operator BC asterisk. Minus, when you convert this, how would it look like? The operands followed by the operator EF asterisk, right? So again, now this looks like what you need to do is you need to treat the postfix converted form to, you need to treat them as operands, right? I told you treat them as operands so that you do not get confused. So what happens? You have three operands and two operators in between. The operators are plus and minus, which are having equal priority, right? So the operators are having equal priority, right? So how do you do it? First, you would convert this, that is A plus BZ asterisk, into its postfix notation. How would it be converted? You would have all the operand values together followed by the operator. Okay. Now we have this postfix notation which has to be treated as an operand. Fine. Minus EF asterisk. Right? So here you have two operands and in between you have an operator. Now how is this converted to its postfix equivalent? Just write all the operands together. So you would write A, B, C asterisk plus, and which is the next operand value EF star followed by the operator minus. Is the idea clear? So this is how you would be converting the given postfix, infix expression to the postfix equivalent. Now we'll see one more example. Now I have just introduced a parenthesis to show the order, asterisk to be given priority, and then slash also to be given priority over plus. This is why I have just introduced parenthesis or brackets here. Now, since you're having asterisk and slash along the same line, as you're traveling from left to right, you encounter asterisk first and then followed by slash, right? So first you would be converting, or first you would be doing this and then later on this. Now, since I've given both of them in parentheses, you may or you can convert them together in a single step also. This is how it has been converted, AB asterisk and CD slash. Now, what did I tell you? How to treat them? Treat the postfix converted intermediate result as an operand. So, you're having two operands and in between the operand you have an operator. So, how is it converted to the postfix equivalent? Just write all the operands together followed by the operator and hence the postfix notation. Okay. So, as we move on to the next question. Okay, I hope you understood it, Atul. So let's get to find out the output of a following code fragments. Now you can expect such questions in your board examinations wherein you would be given with a code fragment. You need to travel line by line and then find out what is the end result or what is the output of your entire code fragment. Okay. Now let's get into analyzing. Now the question asked is, suppose stack is allocated 6 memory locations. Okay, so we are talking about a bounded capacity stack. Now what is a bounded capacity? Bounded in which you have or you are telling a restriction to the given data structure. Okay. Now, if you have a restriction, that means only that many values can be stored inside your data structure. Now, what is it mentioned in the question? You are allocating 6 memory locations. So, actually, we are talking about a bounded stack here with which is capable of holding only 6 elements. Okay. And initially, the stack is empty. When the stack is empty, the top is definitely pointing to 0. And then we'll go to the code fragment and then find out the answer. Okay. Now see here, to find out the output for a particular code fragment, what you need to do is travel each line of the program and then assign the values manually and then find out how this is working. Okay. Now, the question has shown that this is a stack. So, definitely they are going to be push and pop operations. Now, here again, it has been given push and pop operations, functions are given. Now, let us assume that these are user-defined functions. Push is a user-defined function which is actually appending or adding value to the stack. Is the idea clear? Now, you're given with two variables, which are the variables AA and BB. AA is given or initialize the value 2 and BB is initialize the value 5. Okay. Now we are trying to push the values in the stack, right? So let us imagine the stack to be like this. And the first value pushed is AA, right? What is the value of AA? AA is 2. Now the next value pushed would come and fall on top of AA, which is the value pushed 4, right? The next value pushed is BB plus 2. Now what is BB? 5, right? 5 plus 2 is 7. Then the value pushed is 9. Okay. And what is the next value being pushed? The next value is being pushed is AA plus B. Now, which is that? 5 plus 2, which is 7. Okay. So, these are the values that are pushed into your stack. So, when you are done with all the 6 push operations, this is how your stack would look like. Is the idea clear? On top of the stack, the value pointed by top is 7. Now next you are running a loop. Now here the top is going to travel from the current value till it reaches the index value 0. Okay. Now in this case you are trying to print item. Now pop is a method. Now we know that stack would be implemented using list, right? So when you're trying to invoke the method pop, what happens? It would delete the element and return the element, right? It could delete as well as return the value also. Now this value would be saved onto item, and when you're trying to print item, what happens? The value that is right now deleted would be printed on the screen. Now what is the order in which it would be printed? Now right now top is pointing to 7. So when you're trying to print the top of the stack, the value 7 would be printed. After that, top gets decremented to 0.29. The next time, what happens? 9 would be printed on screen. Later 7, then 4 and followed by 2, because I have given top should be greater than or equal to 0, right? So all the values that are in the stack would be popped and then it would be printed on the screen. So let's get to see if this is the output. If this is the same thing that we are going to get. Yes, see, this is the output that we get. Okay. So all you need to keep in mind is the LIFO manner in which the stack is working, and always the top stack top points to the very last element inserted in the stack. Okay. Now, the next question, consider the following sequence of numbers. So, you are given with a sequence of numbers 1, 2, 3, 4. Now, these are supposed to be operated through a stack. So, you're trying to either push the elements or pop the elements from the stack. So, these are the operations. We know that the different operations in stack are either push or pop to produce the following sequence of numbers. So we are doing some sort of operations on the stack to generate this output. Now what is the output? 2, 1, 4, 3, right? So the question that is asked is, you need to list all the push and pop operations needed to get the required output. Is the idea clear? You just need to list out the order of push and pop operations needed to require the output. So this is your required output. Is the idea clear? This is the required output. And this is how the numbers would look like for inputting. Is the idea clear? So these are the numbers that you need to input, and this is the order in which you are expecting the output. Now we need to give the sequence of push and pop operations so that you generate such an output. Now let us see. So the first value is 1, right? So when you are encountering 1, what would I do? I would push 1. So here I've just listed as different steps. Okay. Now whenever you're trying to push, what happens? Whenever you're trying to insert an element, you need to specify the element also, right? Or the data item which you're going to insert into the stack. But when you're popping or deleting, you needn't mention the data element. Why? Because whatever the stack is pointing at the top would be flushed off from the stack or deleted from the stack. Now let's assume this. Let's draw the stack. Okay. You're trying to push 1. So what happens? 1 would be at the bottom of the stack. Now right now top is pointing to 1. What is the next operation? The next operation is pushing the value 2, right? So what would happen? 2 would be pushed onto the stack and it would come and fall on top of 1, right? So where will your top be pointing to now? The top would be pointing to 2, right? Now what is happening? You're trying to pop. How many pop operations? 2 pop operations. When you try to pop, whatever top is pointing to currently would be ejected out. Now what would be ejected? 2 would be ejected. Now top gets decremented. Now 2 is flushed off. So this position is empty. Now top would be pointing to 1. By the time you are initiating the next pop, okay? So what happens? 1 would be popped out and Karthik, yes. Now, as per the timetable that I have prepared, right now we have completed with the data structures, stack and queue, and then the applications which we covered in the last class. Today we just had a simple question discussions on the chapter because this is a pattern that we follow. After each of the chapter, we have been discussing the questions. In the next class, we'll be dealing with sorting techniques and then followed by file operations. After file, definitely we'll be looking into SQL. Now, this is a one in the agenda, in the timetable. Okay, so definitely we'll be looking into it. But I'm sorry to say it would be definitely after the file handling operations. So I would request you to patiently. Okay, fine. Good, very good. Okay, so this is how I have charted my timetable. Fine. Okay, so please follow me so that you get a track of all the classes posted by me in both YouTube as well as in the app. Okay, so I hope you had seen the other applications of stack and queue that we had discussed in the previous class also. Okay. So right now, our top is pointing to which element? The element 1, right? Okay. So now what is the next operation initiated? Again, pop, right? So what would happen? The number 1 would be flushed out, okay, and it would be printed on the screen. Now top would be pointing to none. When the stack is empty, it would be pointing to none and not 0. Now, in this case, what are you trying to do? The next step is pushing. So, what happens? I erased off the entire thing. Okay, so what would happen? Now, 3 would come and fall here at the bottom of the stack because since you have popped out 2 and 1, these are the ones that are going to be printed on the screen. And then next push operation, so 4 is going to fall on top of 3 and here is where the top is going to point. Now when you are doing the pop, you would get the output as 4 and 3. See, what was the question that was asked here? You're given with 1, 2, 3, 4. These are the numbers for inputting and then you needed to generate this required output, right? So this was a sequence of push and pop operations you should have written so that this particular output is generated. Is the idea clear? So I hope this is also clear to you. So with one more question to go and then we'll be winding up today's session. I guess this is the last question. Yes. So here we're going to convert an infix expression to the postfix equivalent. Okay. But the expression given here is a logical expression. Why? Because there we have involved and, or, and not operator. Now here the contents of the stack has to be shown at every step. Now for the understanding we need, though the expression is given like this, we would definitely have an outermost brackets also prior to starting our operation with the stack, right? Now, how do we travel? Definitely, we would travel from the direction of left to right. Now, the actions to be taken. What action to be taken? Whenever you have the opening bracket, it is pushed onto the stack, right? whenever you encounter an operand, it is attached or appended to your postfix notation, right? And then whenever you encountered an operator, what happened? It is pushed onto the stack, but you had to maintain the priority or the precedence order of the operator. Then, whenever you encountered a right parenthesis or a closing bracket, everything from the stack was popped out till you get a matching left parenthesis. So, these are the steps that we need to take care of when you're traveling an expression from, an infix expression from left to right, and you're trying to convert to postfix form using the stack. Okay. So see here, as the scanned elements, you have the, this is how you need to show in the form of a table if you are asked to do so. So you should have the scanned elements in one column, the status of the stack, okay, wherein you would have only the, either the left parenthesis or the operators inside the stack, and expression is nothing but your postfix notation, okay, postfix notation of the given in fixed form. So as you're traveling, I told you that you need to give an opening and closing bracket, opening at the beginning and closing at the end of the expression, and then see the expression once again, scanning from left to right. So opening parenthesis, it is pushed onto the stack, nothing being attached to your postfix expression. Okay. Then you have the operand. Now, true and false are to be considered as your operand values. Okay. So, true, whenever you encounter true, it is appended to the expression. You have the operator and, right? Operator. So, since it is pushed to the stack, then you have the operand, where has it to be appended to the postfix expression. See, true, false. And then now you have a closing bracket. So what would happen? Whenever there is a closing bracket, you need to pop everything from the stack till you get a matching opening bracket, right? Now what is the only thing in your stack? Your stack is the operator and, right? So this would be popped and appended to your postfix expression. Fine. Now as you travel again, then you see or. So you're done with here till here. Now you see which is the operator. You see the operator or, right? So what is to be done? Or would be pushed onto the stack. And this is the postfix expression notation. When you encounter not, it would come and fall on top of or. There is no issue here because not is having a higher priority when you compare it with or. Okay. Now the status remains the same. Now inside not, you're having an opening parenthesis or left parenthesis, definitely push onto the stack. So this is a status of your stack and your status of your postfix expression so far. After that, you have the operand false. Now, where will false be written? It would be appended to your postfix notation. There is no change to the stack here. Now, you see an operator, right? So, the operator after the parenthesis, right? Now, when you consider or and not, actually not is having a higher priority when compared to or. But you see that on top of not, you have the parenthesis. So in this case, you needn't get tensed about the precedence. You can simply push it onto the stack. Okay. After that, you see the operand. True is an operand. It has to be attached to the postfix notation. After this, you see a closing bracket, right? So whenever you see a closing bracket, what is to be done? You need to pop everything from the stack till you see a matching left parenthesis. So the only operator on from the stack would be popped and attached to the postfix notation. Now what happened? The very last closing bracket is encountered here. Okay. I told you that whenever you have the infix expression, the first and the last, the entire infix expression has to be put inside an opening and closing bracket, right? So this is the only closing bracket. Now what would happen? Everything would be popped out. Actually, this parenthesis is here everywhere. Okay, I think I have left it out, right? So what would happen? Everything would be popped out from the stack till you get a matching parenthesis. And one more thing that you need to note here is nowhere in the postfix notation you would be attaching the brackets. You would just have operands and operators. Okay. So what would happen? First, you would be popping not, which would be appended to the expression. Then you have the or, again that would be appended to the expression. So this is your final result of your given expression, and this is the answer. So this is the postfix equivalent of the given infix expression. So this is how you convert it. And if you're thinking about the evaluation of the postfix expression and also the Q operations, we had actually seen it in our, the class. We had worked out examples plus the session. This is how our classes went on. So I think there are no more doubts. There is anything, you can ping me right now. I'm ready to wait for one more minute. So with this, we have come to the end of today's session. So for all those who had asked me about files and then about SQL, we'll be starting them shortly. But right now, we are dealing with data structures. We have just winded them up. We'll be looking into the sorting techniques followed by files. And after the completion of files and their question discussion, we'll be moving on to SQL. Okay. So before bidding good night, let me remind you once again of my promo code SLYT, which would help you in getting a discount of 10% on the subscription fee of Unacademy. So do not forget to follow us in YouTube, subscribe our YouTube channel, and follow me in the Unacademy app so that you get notifications and updates on my upcoming classes. Okay, so thank you all for attending and hope to meet you all soon in the next class. We have a session tomorrow. My YouTube sessions are usually at 8:30 p.m. Okay, so thank you and good night.